So the next set of transformations we're going to talk about is reflecting, and then we'll get into some stretching as well, because I know you guys want to, cap it all off. All right, so reflecting. So if we have negative out in front, so here's our parent function right here once again. If we have a negative out in front, we're looking at the red graph here. It's reflected about the x-axis, which is a vertical reflection. It's moving from up here to down here. It's reflecting over that x-axis, that line right there. So basically, all my y values change sign. Okay. Now if I look at from my parent function to the green guy, I've got my negative inside the function, inside with the x up top there in the exponent. That's going to reflect about the y-axis. That's a horizontal reflection. I'm moving from side to side. And that makes sense because my horizontal transformations need to happen along with that x up there. My vertical reflections happen out in front. Okay. Or outside the function, rather. So it could be at the end there where you're adding or subtracting, moving it up and down. It could be out in front. Okay. So that's basically it for reflecting. And what happens when you reflect over the y-axis, or it's a horizontal reflection, your x-coordinates end up changing. Okay? My y-coordinates will stay the same, but my x's will change. Now the nice thing about reflections in graphs is if you're graphing a line, it's going to work itself out in the t-chart that you make, so you don't have to worry too much about the reflections. But I could ask you a question with a function and say, like, what's happening here? Oh, it's a vertical reflection over the x-axis. What's happening here? Oh, it's a horizontal reflection over the y-axis. So you would need to know those types of things, but it also works itself out in the t-chart of the graph, which is great. All right, next we're dealing with some vertical stretching and compressing or shrinking, if you will. So once again, we've got our parent function in blue there. Wonderful. Now let's look at the red graph. The red graph, I have a 4 out in front. Since that's greater than 1, it's going to be a stretch. You can also see that it's going to change my y-intercept, because if I plug in 0 for x, 2 to the 0 is 1, times 4 is 4. That's my new y-intercept. So that number out there and the number added or subtracted out back affects my y-intercept. Even numbers added or subtracted up in the exponent as well. But that's all just super duper fun. All right, the next one, we've got our green function here. We got a 1/4 out in front. That's going to shrink the graph, right? It's going to vertically compress it, if you will. So if it's between 0 and 1 for this value out in front, it's going to be a compression. If it's greater than 1, it's going to be a stretch. Awesome. And these are going to work themselves out in the graphs with our t-charts. You'll get different y values because of those numbers. You don't have to worry too much about them in a graphing sense. But if I ask you, what's the transformation? You need to know it's a vertical stretch by a factor of 4. Oh, it's a vertical compression or shrinking vertically by a factor of 1/4.